Compound interest. What compound interest is, you not only earn interest on the principal, what you invest, but you also earn interest on the interest, which is always a good thing. So what you have here is a formula that has an exponent. This one finds the future value, and this one will find the present value. Kind of way to think about it. Future, present. We'll do some examples here in just a second. But before we do that, notice that A is the amount including principal and interest. That's the total amount of money. P is the principal, that's what you invest. R is interest rate as a decimal. T is the time. And N is the number of compounding periods in a year. So let's look at the N. If it's daily, we're going to use 365. That is not a 6. This is a 6. 365. Unless the book or whatever you're doing says otherwise. It may say 360. Weekly, it is true. There are 52 weeks in a year. Monthly, there are 12 months in a year. Quarterly, how many quarters are in a dollar? 4. Semi-annually, how many hemispheres are there? Hemispheres? Semicircles make up a circle? Well, that's 2. Annually is once a year. So now let's do some examples. Hopefully, look at that. Got that? Okay, here we go. Find the amount of money in account if $100 is invested for 4 years at 3.9%. Compound it monthly. Compound it. That tells us immediately we're going to use the compound interest formula. Hardest part of this is actually finding the answers from your calculator. So start with the P, which is $100. That's what you're investing. R, 3.9% is the same as 0.039 as a decimal. And then monthly, there's 12 months in a year. That's why I did this up here. 12 times T, which is 4. Now, if you need to, before you start using your calculator, you might want to recognize that 12 times 4 is 48. I don't know. It just depends on your calculator, on how you want to approach it. So I'm going to, with the graphing calculator, I'm going to just type it in all at once, because it is easy to do it this way. And with this calculator, it makes it even easier because, oh, this one doesn't do what I thought it was going to do. Some calculators actually bring up an exponent box, which makes it really easy. All you got to do then is type in 12 times 4. Now you can use the 48 if you want to. If you're lazy, like I tend to be, you can just go ahead and use parentheses around the exponent. 12 times 4. And then hit enter, and you get your answer. 116.85. And like I said, if you wanted to, you could have just tapped in the 48. Now, if you're using a scientific calculator, you must do the 12 times 4 is 48. You have no choice. And then what you want to do, you want to work inside parentheses first, do the division first. 0.039 divided by 12 plus 1 equals. And then you may have that kind of a key right there. That's an exponent key. So then you type in the 48 equals. And then times that by 100. And you get the same thing. So just be aware. That's how you do it with the scientific, if you need to. Now, same type of example. 2.8% is 0.028. Semi-annually is twice a year. So let's take our formula. You may have a different variation of the formula in your book, whichever book you may be using. This is by far the best one though. I don't know why I put the P there because I don't know what P is. P is 2,500. Because we're asked to find the total amount of money in the account if you invest 2,500. So that's why I put the 2,500 as P. R is 0.028. N is 2. And then T is, I really don't like using parentheses there. It it can mess you up with the calculator. T is 9. And once again, if you need to, make that an 18. Now how you do it is totally up to you. I tend to like to use my graphing calculator because I can type it in all at once. And just to save a little time, since I already have it as 18, I'm going to put the 18 there. And that's going to be my answer. 0.87. See if I can fit that in there. Yep. Now this question is a little bit different. This time you're asked to find how much money should be invested. So this time you don't know what P is, and you're given the A. So that's where you got to use this formula, the present value formula. P equals, it's the same as this one, I actually saw for P, we need to get that. Once again, it would be provided for you if you're in my class. So this time we're going to do P equals A over 1 plus R over N to the NT power. So A is 10,000 over 1 plus R, that is an R. R is 0.041. Quarterly is 4 times in a year, so that's 4. And then 4 times 10. 10 is a T. So on this one, has to be a little careful. Let's see, just do 10,000 divided by open parentheses 1 plus 0.041 divided by 4, close, raised to the 4 times 10 is 40. So probably better off just going and using 40 there to avoid having to write down all kinds of parentheses. And you get $6,650.37 around the nearest cent. Now what I'm going to do, I'm going to use a scientific calculator. And this may not be easy to use, by the way. So I definitely have my 40. So let's take inside parentheses 0.041 divided by 4 plus 1 equals, and then raise that to the 40th power. And I need to write all that down. And the more decimals you use, the better off you're going to be. So let's just go ahead and write down all those decimals. 1.5, well, not all of them, but we'll use quite a few of them. 3676. And this is just to be as accurate as possible towards the end. The rule is don't round to the very end. 503676334422. 33422. So let's just use that. Hopefully that'll be enough. So we have 10,000 divided by 1.503676334422. Yeah, it's pretty good. So use quite a few digits just to be safe. Now if you know how to use your memory keys, you can do that. There's other keys you might possibly have. You might have like an inverse key. I don't know if I want to show that or not. It's probably better just to go ahead and write them all out, just to be totally honest about it. So that's for the present value. Now we got a couple of different examples. This example down here, you're going to be asked to find the number of years, which is the T. So that's an exponent. In order to find exponents, or to solve for exponents, you have to use something called logarithms. Log for short. And so what we have here is an example on how to do that. So we're going to solve this 4 to the x equals 2. That's the equation. We got to solve for x. And if you're brand new to this stuff, this is brand new. Before I actually go over this, on the graphing calculator, you have a log key right there. On a scientific, Hopefully this has a log. There's a log key there. That's always good when you have a log key. So yours should have one somewhere also. So to solve for the exponent, all you're going to do is put the log, write the word log in front of both sides. That's the first thing. So that's what it means by taking the log of both sides. You write the log in front of both sides. Now there's a property you got to use after that. And that says that you got to take this exponent x and it moves out in front. So take that x, it's going to move out in front. So it becomes x log of 4 equals log of 2. And that's actually a number. So if you want to write it like that, you can. And to solve this, we need to isolate the x. So I'm going to write it as, just as it is. Log 4, x log of 4 equals log of 2. To solve it, that's considered a number. The whole thing is, all that is a number. So to get the x by itself, you divide by log of 4. Let me write that a little bit better so you can see it, in case you're wondering what that really is. It's just the word log. So you take the log of both sides, you move the x out in front, and then you divide by the log that's with the x. And those will cancel out, leaving x. And this is just an approximation. So we're going to take out our calculator. I don't know what's going on right now. Oh, finally, I made it back. So we're going to take our calculator. And I'm going to type in the log. Notice the parentheses pops up on this one, so I type in the 2. Make sure you close that parentheses. Divided by log, and then the 4. Enter. So, and you get 0.5. That's what you get. Now for a scientific calculator, you gotta hit the 2 and then the log key, and then divide that by 4 and then the log key, and then equals. That's how you do the scientific. So here we go. We're going to try to solve for the number of years. And in order to do that, notice it's compounded monthly, so it's a compound interest problem. So we're going to use this formula once again. This one could be quite difficult, so just be aware. So our A is the final amount, which is the 5,000, and the P is what you started with, which is 1,500. So we have the 5,000 equals the 1,500. 1 plus R. R is 3.1 as a decimal. 0.031. Monthly is 12. And then 12. And the T we don't know, so you leave it as T. Yes, this is going to be a fairly difficult one, so just be aware. So what the first step is you want to do here, you could go ahead and just add all those together, and that's fine. And in fact, I think I might want to do that, just so I have fewer numbers to look at. So let's take the 15, or the 1 plus 0.031 divided by 12. And you get, I'm going to type in all those numbers. 1.002583333. I don't round out to the very end. 12t. And then just what I'm going to do now is start to eliminate numbers that are with the t. So I'm going to eliminate the 1,500 first. It's easier to do first. So let's divide both of those by 1,500. Those will cancel out. We end up with 5,000 divided by 1,500. We get that. Once again, I'm not going to leave anything out. 3, 3, how many are there? 3, 4, 5, 6, 7, 9. And you may not need to write all those out, but I'm just going to be safe. I don't have to use the parentheses anymore either. I'm running out of space. So what that means is I'm going to have to come down here somehow. And this is going to be messed up bad. So just be aware of what's going to happen. Oh, good. Nothing's happening. Ah, good. I was a little scared. It's all good. It's all good. So now what I'm going to do is, remember what, when you get to this point right here, you want to take the log of both sides. So what that means now is, once I write all these down, is that 12t will now move out in front. And hopefully I don't leave anything out. Remember what we're trying to do, we're trying to get the t by itself. And since this is all multiplication, I'm going to divide everything by anything that's not t, which is 12 log that ugly number. Both sides. Because those will cancel and that will cancel, leaving just a t. Phew, I bet you're loving this right now, aren't you? I'm going crazy. Everything's going all over the place with this example. So once again, with the scientific, I'm just going to type in, as it is, log 3.133456789 divided by 12 log, make sure you close parentheses up there by the way, 1.002583333. And we get a strange looking answer. And so when you look at that answer, when you take me to the e, the negative 5, which I don't like the answer whatsoever, just won't be honest about it. There's a decimal there. That means that's scientific notation, so you move that 5 places to the left. 1, 2, 3, 4, 5. And that's the answer for the time, which makes no sense at all for this example. But hey, it is what it is. Now for the scientific, let's clear that out. We're going to type in 3.33333333 log divided by, how are we going to do this? 1.002583333 log, enter, and divide that by 12. Probably be the best way of doing it. That actually makes more sense. So let's see what I did with the graphing calculator. Oh, yeah, I did it wrong, graphing calculator. Watch this. I should have typed this in parentheses, so I can hit second insert parentheses. If it doesn't smell right, it's probably not right. There we go, yeah. Doesn't hurt to use two calculators just to verify. So that was incorrect because I typed it in wrong the first time. 38 point, let's just call it 9 years. That sounds way, way better. So I typed it in wrong. I should have put all of this in parentheses. Got that? That's what we got with the scientific. Yeah. Yep. Learn from my mistakes. Doesn't hurt to make mistakes. You can always learn from them. Yeah, that's the last example. That's good.